Okay, so now we're going to talk about the exponential probability distribution. So far for continuous variables, continuous random variables, we've talked about three different types of distributions. We've talked about the uniform probability distribution, we've talked about the normal probability distribution, and now we're going to talk about the exponential probability distribution. So I just want to show you what it looks like real quick. It looks like this. Right, so that's the shape of it typically. So you notice how it's different from the uniform, which is flat, and the continuous, the normal probability distribution, which is that bell-shaped curve. So for exponential probability distributions, when would you have data that look like that? It's used for random variables such as the time between arrivals at a hospital emergency room, the time required to load a truck, or the distance between major defects on a highway. So basically what it comes down to is the exponential distribution provides a description of the length of the interval between occurrences. So basically we're looking at the length of something, whether that's in time or whether that's in distance. We're interested in the length of that interval. So right, the time between arrivals at a hospital emergency room, right? What is that window? What is that time frame? Or the time required to load a truck, right? How much time does it take, right, to load that truck, right? You have that interval. What is it? What is that length, whether it's in time or distance, like I said. So this is the exponential probability density function, which we can use to create the, to calculate the probabilities, which is down here. The cumulative probabilities is given down here. So again, you can use these equations, or we can just use Excel, which is what we will do. But again, you'll see a similar format in terms of the density functions for these as we've seen for the other ones that we've looked at. So if you'll look at this distribution again now, you'll recognize that 0, right, is the low end, and that makes sense because when we're dealing with time and distance, which are both continuous variables, right, the lowest value they can take on is 0. You can't have negative time or negative distance. So that's sometimes what happens with the shape of this distribution, is it gets kind of skewed because you can't have anything below 0. So typically you'll have a lot of values that are on the low end, 0 to whatever, and then as you get these higher times or distance, they become less likely. So that's where you get this shape from. So let's go through an example, because again, in principle, the ideas of calculating the probability are similar as what we've learned about so far, but now we're just dealing with a different distribution. And the important thing is recognizing what type of distribution you have, because obviously when we go to calculate the probability under the curve, right, it's going to be different whether it's a uniform, a normal, or an exponential distribution. So we have to know what type of distribution we're working with so that we can properly calculate the area under the curve to properly give us to give us the accurate probabilities. So let's say that we're looking at loading time. So for ships loading dock, let's assume that the random variable x is loading time in minutes, and that the average time u is 15 minutes. So first of all, you'll notice that there's no standard deviation like we've seen in other problems, for example with the normal probability distribution. So a property of the exponential distribution is that the mean and the standard deviation are equal. So sometimes if you're not given the standard deviation, think about, okay, is this because it's something I should know, or is it because maybe I'm dealing with an exponential probability distribution? So again, here's the formula that you can plug it in to calculate the probability. All right, you can easily do that, or you can use Excel, which I'll show you in a second. So we're going to look for the probability that loading a truck will take 6 minutes or less. So if we look at our picture, we're looking at this area here, 6 minutes or less. So this area here. So all we have to do is plug that into our function in Excel, which happens to be exponential distribution, expon.dist, right? So we want less than 6 minutes, so we can plug in 6, and then we plug in lambda, which is equal to 1 over, or 1 divided by mu. So it's 1 over 15, and then it's true because it's the cumulative is true, right? We want all the area cumulative up until this point. So we can do that. So let's do that in Excel. All right, so I already have it written out for you down here. Let me zoom in a little bit. So again, it's equals expon dist, right? And it's asking for x, so for us that's 6. What is lambda? 1 divided by mu, which is 15, and then cumulative is true, and boom, 0.3296 or 97, depending on rounding, right? So that's the answer right there. Now, what if we want to calculate the probability of loading a truck in 18 minutes or less? So again, right here it is up to 18 minutes, so we can just find all of this area in here, the cumulative probability from 0 to 18. So again, we can do this in Excel, and it's the exact same thing as what we just did before, equals exponent.distribution, right? We're looking for 18. What is lambda? Is equal to 1 divided by mu, which is 15, cumulative is true, and boom, 0.6988. 0.6988. So what if we want to calculate the probability that loading a truck will take between 6 minutes and 18 minutes? Right, so we want this darker shaded area between 6 and 8. Well, again, it's exactly what we've learned about before. When you calculate the area between two values, we're going to subtract one from the other. So we're going to subtract the 6 from the 18, right, so that this area goes away and we're just left with this. So let's do that. We're subtracting 6 from 18. So if we do that in Excel, equals 6, we're subtracting that from 18. So there's 18 minus the 6, right, 0.3691, right, 0.3691. So that's more or less how you do that. So again, similar principles in terms of how to calculate the probabilities, but instead now we just have to recognize, hey, what type of distribution do we have to make sure that we're using the correct function in Excel. So let's just take a step back and think about what the relationship between the Poisson and the exponential probability distributions is. So remember, we learned about the Poisson in the last chapter, which was discrete probability. The exponential is in the chapter about continuous probability distribution. So that's the biggest difference right there. When you're dealing with the Poisson, you're dealing with discrete variables. With the exponential, you're dealing with continuous. So that should be a big indicator as to which distribution you should use. So typically Poisson, that's the number, right, because it has to be discrete. So the number of something, whereas exponential is dealing with continuous, so usually that's time or distance. So if arrivals, right, the number of arrivals, so think about the number of customers arriving, right, it's a discrete variable. That follows a Poisson distribution, so then the time between the arrivals must follow an exponential distribution, right, because the time is a continuous random variable. So that is going to be exponential. Right, so again, exponential is continuous, Poisson is discrete. So the Poisson distribution provides a description of the number of occurrences per interval, right? And again, remember it's per interval, right? You have to have that window. And again, it's the number of something is usually whole, like the number of occurrences, the number of people arriving, the number of cars being sold. That is a discrete variable. Whereas the exponential distribution provides a description of the length of the interval. So length, right, is a continuous variable. So again, for an example, for Poisson might be the number, right, that's discrete, of shipments in a 1 hour interval, whereas the exponential would describe the time to load ships, for example. Remember, time is continuous. So just comparing those and understanding, we talked about Poisson and exponential, what's the difference? Right, Poisson is used with discrete random variables. Exponential is used with continuous random variables.